Okay. Um, Starting with the conditional statements, so-called branching out in Python, and we will switch to the iterative statements today. So two concepts to be discussed together today, and also hands-on lab. So we'll go this so fast. Conditions in dictionary means the state of something with regard to its appearance, quality, or working order. In coding, you need to make some decisions here, okay, some comparison. If the result of that comparison true, then it goes to one branch, otherwise goes to another branch. So branching statements in Python, in language, is very simple. So if and else statements possible, or if it has multiple conditions to evaluate, then you will have if, elif, 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 elif until you have the rest of the case. Then it'll be called the else statements. So in the if part of this conditional statements, if condition is evaluated to be true, then it goes to the next line of the code after the colon. So this is the code block for the case of true conditions. If false conditions, then it goes to action 2. That comes for the multiple conditional statements as well. So we start with the predicates. What is the predicates? Predicate means that is a statements that can be verified to be either true or false. So false statements is not only called the predicates. Any statements, if they can be verified, either true or false, then it is called the predicates. So this is a typical predicates. Age is greater than or less than, greater than or equal to 21, and less than or equal to 36. Then this is the predicate, because if you give me the age, then I can tell whether your age satisfies these conditions. Right? My age doesn't satisfy this, but I think Kevin, your age may satisfy this, right? Okay, so in general means many languages, many other languages, Java, C, many typical languages, to represent this kind of conditions, then we need to split that into two conditions. Because the condition itself has only one operator and two operands. That's a typical. This condition has two operator, right? And then one variable and two operands, three operands in this case. So this is not typical language, although it is true in math. So mathematics says, yeah, this is true. But in coding, typically, we don't take that into considerations. So we need to split it into two conditions. So one condition is to compare with one operand, 21. Another condition is to compare with another operand, 36. And two conditions are combined together. So this is a logical connector. We call that 2 ampersand. It's called the AND operator. However, we are lucky because we are Python coder. So this still works. So math expression works in Python. It's good news, right? Conditions or the predicates can be formed in this way. Operator in between the value and in between operands. So one operand can be a variable, the other operand can be a value. For another operator, two operands are variables. That's possible. Example for that is if height is less than or equal to depth. So this is a variable and another variable. We need to evaluate this variable and that variable and compare those two variables based upon this operator. Then we can tell that predicate is true or false. Lastly, only one variable can be a predicate. Only one variable can be a condition. Because this variable itself is a Boolean. Variable can be evaluated to be anything but true or false, which means that is the predicate, right? Because it gives me true or false result. For example, red light, that we know, true or false. Green light, red light, yellow light, itself is a conditions, predicates. So we have conditions. Say data equals input. We can say enter your age in integer. Then we can say 18. Then data can take the value entered by a user. And then data is compared with operand. So these predicates may give us true or false, then that is based upon that evaluation result, we can execute the action right after that colon or else statements. Kevin, does this work or not? As is. Why not? Oh, thank you. Very good. Input function returns string. So data is a string. In this if statements, the predicates, that string is compared with the integer. String cannot be compared with the integer. Integer can be compared with the integer. Therefore, we have to convert this string to integer. By the way, there is a function called the int, right? This is a built-in function. Int takes a value. If that value can be converted to integer, then it will return the integer. If the value itself is not convertible to an integer or a number, then gives you an error. You can say also, you can take two user inputs and each can form a predicates together combined with the logical connector, and all will be the conditions. So if both are true, then it goes to next line. Otherwise, it goes to else statements, right? Two predicates are combined by AND logical connector, then together will be true if both are true. If any of those two cases is not true, then all together will be false, right? That is like this. Say this is a predicate 1, this is a predicate 2, and predicate 1 and predicate 2 if this is true, both are true, then this AND operator will be true. If this is true and this is false, if this is false, the other is true. If both are false, this cannot be, then all of those are false. This is things. So we looked at that already. Okay, so iterations. Both the conditional statement, branching statements, and iterations are very common in the coding. If our codes needs to manipulate massive data by the same operations. For example, tax computations. IRS, right? IRS computes your tax informations, but the same operations, right? Same rule will be applied to each and every one of the people. How many people? Well, that's massive data that needs to runs continually. That is iteration, repetitions, right? Same operations needs to be done a million times, millions times. Each operation inside, if you look at, then it has a lot of branching statements. For example, if your income is greater than or less than some number, and also if you have children's, if you have some education payment, if you have some student loan, if you have something, if you have a health care expenses over a certain number, if you buy homes or if you sell homes, a lot of those things. You want me to stop?
No.
And it goes on and on and on. Okay, so how can the same code segment be performed iteratively? It's based upon the number of times. Okay, so we can specify how many times. Or we can say, hey, each element in a closed world, those closed world will be a data type. For example, a list, then that is a limited number of elements there, right? 1, 2, 5, 3, something like that. It's a limited number of the elements that, based upon data types. Well, or if you want to read a file, then file is always a limited size of the file. So you can say each element in that file. That is another thing that you can think of. Web pages. If you receive web data, then that is a limited size of the data. So that is a for loops. For loop for a given number of times. For loop based upon closed world. Or you can say while loop, while some condition is met. So iterative statements has for loop cases and while loop cases. So this is a for loop. For loop can, yeah, both are for loop. The iterations. One case of iteration is that you can repeat something from large scope, and you can reduce the scope until there's nothing. This is possible, right? Another thing is you can start from small case, and then case grows, and grows. Then you can specify until the size. So you need to specify the terminate size. Then when it reaches that terminate conditions, then your iterations will stop. Similarly here, terminate conditions in this case is the empty. If there is empty, then that iteration, that repetition will stop. So iterative statements, we have for a number of times. For each in a list, for each element in a file, or while some condition is met. Those are the general the cases that we can consider for our iterative statements. So for the first case, for number of times, then you can say for each in range 1, 5, then because this range gives you 1, 2, 3, 4, 5, so you can print that. Okay. I believe the range gives you only, yeah, starting from 1, but this is the ending number, but ending number is not included. So we'll take that little bit of the exercise here. Let's say for I in range 1, 5, and then if you want to print I, then you can simply see what i's. So 1, 2, 3, 4, right? So that is the case here. So it gives you the number of iterations. So 1, 2, 3, 4. So 5 is not included. So from 1 to 5, but 5 itself is excluded. Another one is for each in a list. So we can say list is, this is the list. And then our statement says for each in a list, and we want to print, then we can print 1, 3, 7, because we want to consider one element at a time. 7, and the next one is 2, and next one is 9, next one is 19, and next one is 11. That is a case of for each in a list. What if we have a for each element in a file? Then to do that, you have to do with open a file. You need to have a function, built-in function called open. Open is a built-in function, built-in and then standalone functions. User file, you need to specify fully qualified path expression to the file, then your Python understands which file needs to be open. When the file is open, then we call it f. This f is nothing but a file. So as we looked at here, for each element in a file, so for each in f, in file, for each in a file, so we want to print. While loop. Like we have a for loop here, we can say while some condition is met. Then we can say while true, print x. If x is greater than 100, then break. Other than that, we need to increase the x. After that, we need to increase x equals x plus 1. If we don't say this, then this goes forever. For the case of x, if x is initially 1, then print 1. 1 is not greater than 1. So another iteration, another iteration, another iteration is endless repetitions, right? To avoid that, you need to have the increment so that it can grow and grow until 100. After 100, then it'll stop. That is a while loop. So iterative conditions, starting with the initialization, and condition is compared. And if that is true, some updates and go back. Therefore, next condition is not the same condition as previous. If they are the same conditions, then it goes forever. So next condition evaluation is different from the previous. Therefore, this changes until false. If it false, then loop will end. Example, we have lots of examples, but we'll take that in the lab. Built-in functions, open is needed when we deal with a file. Open functions has a file name and mode. If this mode is all, then we want to open for reading. W, then we want to write. A for append, we want to continue to append. If you want to deal with any binary code, for example, packet analysis, then rather than do some plain text, we need to use binary data. So you need to deal with RB, WB, and things like that. This is for cybersecurity professionals use this more often. Reading files. Let's say you have a temp file .data contains this values and read the data. Then you need to first open the file name, open, and then this is open the file. So for line in that file, then we can print a line by line. Okay. This is the case for the Windows users. File equals open, then Windows users, JUN, desktop, py string.py, you want to read. This is a mode, open mode. So using open, then you need to specify this. And then file.read, then you can read all the files. File.read lines, then you can read all in lines in a, this is a split lines. we can look at that in a hands-on exercise. Okay, here is a hands-on exercise. Let's start with the predicates. So do you have this notebook, Kevin? Bring that notebook on your Google Colab. So predicate is the form of term, operation, term. We have operator and then two operands, where term should be evaluated and operation is comparison. So the evaluation of a predicate will be either true or false. So is this a predicate, first of all? Kevin, 5 is greater than 3. Is this a predicate? According to this, yes, it is a predicate because we have a term that is evaluatable and 3 that is a term. And in between we have an operator. So it gives us true or false. 5 is greater than 3, then it gives us true. So this is a predicate. We can consider a list and we can make a predicate. Let's say list LST, and then second element in the list. So list of 1 equal 4. Is this true or false? Is this first of all predicate? Then we need to see if first one is evaluatable. List of 1, then there's a second element, number 8. So that is a term. And then second term, that is number 4, literally. And then in between, we have a equal sign, double equal sign. So that is an operator. So that is the predicate. So that we can evaluate entire this predicate. Then it'll return, gives you true, either true or false. Is 8 equals to 4? Of course, it's not true, right? So that false. So that is, we know what it is. So this operator at one side like a variable and another side the value. Let's say next ones. This operator greater than operator, left hand side the variable, and right hand side literally that is the variable, right? So LST index 2, then we know what it is. Max LST, we know max, it gives us the maximum number. So entire, we know what it is. We can evaluate that. So third element in the list, that is 23. Maximum of this LST, what is it, LST? That is also 23. Is 23 greater than maximum 23? No, why? Because 23 is not greater than 23. 23 is 23. If there is equal sign, then it'll be true, but because we said greater than, so it is not. Right? Okay. Length LST is greater than or equal to 4. What is that? Len is a built-in functions. So it gives us the size of the list. Size of a list. So how many elements? We have 4. So 4 is greater than or equal to 4. Yes, it is, right? So that is true. Another one is LST dot index 9 is greater than 3. What is the index 9? Index 9, then 9 is the value, goes to this list. So what is the index number of 9? Then the first element is index 0, second element is index 1, index 2, So this is index 3. So that is. That is a predicate. So if we run this, first one is false, because we didn't print this. If we have printed here, then we can have first one is true, second one is false, second print statement here, that is false, third one false, this is true, and that is true. Okay? Make sense? Boolean is also possible. For example, list is this LST here, right? Let's say I want to put here list. So given list, I want to append the true, and then append the false, and then print again. So what happens? Given list is 4, 8, 23, 9. If I append the true, then it'll be 4, 8, 23, 9, and true. True itself is the value. False itself is a value. If we have here upper side, uppercase. More predicates. What is the type of LST? That is a list. Is instance LST is an instance of a list? Yes, that is true. Is LST is tuple? No, it is not, because it is a list. Is LST dict? No, it is not. Right? So all of this, for example, this is a predicate, because it gives us true or false things. Okay? It can be a conditions. For example, data equals to and then we can say my DAT equals date and data 2, and for each in my DAT, and now if each is instance this instance EH is a list. If it is a list, then we can say, because that is a list, we can do append 11 and then print. Print error. DAT3 equals, this guy is smart, 3. Okay, so I want to make, I want to run this, see what happens. So in this, I have a list of data, multiple other data. So first one is tuple, second one is a list, third one is a dictionary. So for each of these data types, If is instance that data type is tuple, then we simply print it. If data itself is a list, then we can manipulate it. We can add it. We can append it. Therefore, tuple remains the same. And we can say can be modified. If it is a tuple, then it remains the same. If it is a list, then we can make it modified. Other than that, we can simply say that gives us an error. So conditional statements, as we looked at in the slide, if predicate, then action. Or we can say if predicate, action 1, if predicate 2, action 2, and then we continue to do that. Let's say this. Minimum legal drinking age, MLDA, minimum legal drinking age. What is the minimal legal drinking age in New York? 21. Oh, you started drinking at the age of 18? Yeah, I remember when my son was, and after high school, but not yet 21 years old, right? College students. So, but sometimes he had a party with his friends. He still buy the alcohol. So I asked, "How did you buy alcohol?" He showed it to me, his fake ID. Do you used to have your fake ID? Even before the age of 21. So what state was it? Some other states, some Midwest, some Arizona, Kansas, that area, they sell the fake ID, right? Your friends has, some of your friends has also
Yeah, I know.
fake IDs, right? To buy alcohol. Okay. So this say print, can I buy alcohol? So can I buy alcohol? Enter your age. If you say 18, enter, then it gives you false. So if you look at the code here, age, and then we didn't say anything, but print age is greater than or equal to 21. Then it gives us false. How come it is possible? Because this predicate gives us true or false. Right? Rather than saying here, if we say if age is greater than or equal to 21, then you are, yes, you can. Other than that, you cannot. The very same ones can be done like this. If you use if then else. The above examples gives you true or false only. But the next one is you use if then, if else statements, conditional statements. Above, no conditional statements, but you can evaluate to give you true or false type of things. Because can I buy alcohol? False. That could be an answer, right? Or like here, can I buy alcohol? No, you cannot. You can say more explicitly. How come it is possible? Because this is a predicate. The same predicates can be explained more. Okay. Iterations. As we looked at the two types of iterations, for loop or while loop. So we looked at this. For I in the range 1, comma 5, then our considerations is 1, 2, 3, 4. You can also do, for example, the simple coding is you want to add 5 to 20, any number between 5 and 20, not any number, each other number, or by stepping 2. So either odd number or even numbers between 5 and 20. If we start from odd number, then all the way odd numbers, because of step 2, before 20, and we sum them up here. Okay, so that'll be 96. The very same ones, if we want to show the explanations of that computation, then it'll be 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17 plus 20, 19 plus 96. But this expression is not true because the last one is not really equal plus sign, but rather plus sign if you want to put equal sign, for example. Then this for loop, inside the for loop, then you need to say, hey, if this is the last ones, then rather than equal sign, I want to put the, rather than plus sign, I want to put the equal sign. Other than that, as is, all the plus sign. How about that, right? So there's homework assignments here, okay? So like, if this is not the last, then plus a sign. If this is the last, what do you mean by last? Here, 20, right? So for example, if I equals I think 19 is the last ones, right? So if it's 19, then we can say equal sign, else plus sign. If we do this, then it'll be like this, right? Actually, that is the homework number 3.1. Homework number 3.2. I want to make a trees, like Christmas tree. This is homework number. I need an exercise. I think here is an exercise. If I run this, then gives you this. So what it does is that we have for loop, range 1 to 13. So up to 10, I want to make a star. If it is greater than 10, which means this trunk. In the case of a trunk, I want to make first 8, that is a space, and then I want to make 3 stars. That is a 3 star here. I want to do that if I is greater than or equal to 10. So 10, 11, 12. I want to do that. Other than that, so for example, I equals 1, 2, 3, 4, 5, 6, 7, 8, 9. Then I want to do a little bit of that. So two one dot, I believe that is a 10. Print, for example, star times I, then it'll be like this, right? 1, 2, 3, 4, like that. If you want to make first line 1 star, next line 3 stars, and 5 stars, 7 stars, if you want to make that, then you need to do, for example, 2 times I plus 1, right? No, minus 1. See what happens. If this is 1, then yeah. Then it'll be, first one is 1, second one is 3. So first one, 1, second line 3, third line 5. Then how many times that you want to print stars? 2 I minus 1. So that is from 1, I want to jump 2 each. So 1, 3, 5, 7, like that. So this can make this tree from here there. But only the issue here, I need to push this to the center, right? I want to make some space. So I want to make space. Let's say, how many space that I want to make? Try with that. Then I have this many space, right? But I want to make it this the other way. The first line, I want to make more space than others. So that space needs to be reduced. So what that means here is, from 10, I want to reduce. Okay? Then it'll be something like this. So this is very similar to that, right? So triangle, above a triangle, can make this. And below trunk is simple, right? Trunk can be done simple. This is above a triangle. If we want to make a trunk, then you can see 4i in range, I think range 3. So range 3. I want to make 8 spaces. If we combine these two, then it'll be this. Similarly, I want to make a more dynamic ways. If I give you 10 and 3 and 20 and 3, then 20 heights of the triangle, and then trunk, 3 trunks. If I say 50 and 50, then above triangle 50, and lower trunk 50. That's what I ask you to do. Okay, that is a code. There's homework assignments. Okay. So far, any question? This is, I think you guys already know. Now, using iteration, I want to read the file. Okay, so I need to prepare reading files. Give me a second, so I need to get the files. Let's see. Okay, so I posted a sample file to read on Blackboard, Kevin. You can download this on your local somewhere here, and then on your here, this is your code. Remember that we need to specify the file path and then open it, right? So what we need to do is, let's say initially this is nothing here. How can you read? How can you specify your path expressions? If that is a local, your the platform, either Windows or Mac OS, then you know how to get that path expressions. Here, Google Colabs, if you open the left side here, that is a folder icon. There is a sample files. You can simply read these sample files. If you want to read these sample files, then you can say here, copy path, and then put that path here. And if you run this, this may be a long list. This is a long list of the files, right? So I do not want you to play with that because that is too long. What I want you to do, I want to remove that. Rather than using some of this, I want to work on something that I have on my laptop. So data is simple like this. Okay. So we have here user ID and device models. So user ID number 1, device model is Google Pixel 5, operating systems, Android, app usage time, minutes per day, then 393 minutes per day. And next one is screen on time, hours per day. How many hours for screen? 6 hours per day. And then battery drain, milliamp per day. So 4 milliamp, 1872 milliamp per day, and so on and so forth. So this is the data, right? And I have only 10 records plus column head. That is my data. So how can I read this data here? To do that, we have to first include that file from the local drive to the Google Drive. So open here, that is the icon, upload to session storage. So what do we mean by upload to session storage? Even if you upload the file, if you change the session of this Google Colab, you don't keep that file forever. Only that session remains, then you will have that files. That's what it means. Anyway, so it'll be gone. It's not persistent here on Google Colab. Google is so smart, so they don't want anyone to keep any data on their Google Colab. There's some legal issues, right? If somebody is save their malicious code on their Google Colab persistently, then we do not know eventually what it would happen, right? So if a session is changed, then files stored on the Google Colab disappears. Anyway, so for this current session, let's bring the file available on our Google Colab. By clicking this, then I have somewhere here. Let me change that and come back here. See if I have. CSV files. Oops, it's not here. 505. Maybe it's there. Oh, not this. No, yeah, it is. Let me see. Cancel that. See, where are we? Yeah. Okay. I cannot see it. Oh, here. So CSV comes up here. Okay. Then I have here user underscore behavior underscore data set dot CSV file. That is this file. So I want to get that path expressions, copy path, and bring that here, paste it. And when I run this, then I have very nice data that I had here, right? Same data. So what I did is that I used open built-in standalone functions. So this is an object, file pointer object, pointing to that file, and I can read it. You can do this, or you can use a for loop. For each in file open, and then print each. If you run this, you still have that, right? But this is a line by line. So we can say, for example, line for I, you can say For example, if we have enumerate functions, enumerate functions can give us the order of that set, whatever the set that is. For example, file is a limited set. In that set, you can attach the order, which is I. This is the index. Each is the content of that. I is enumerations. So we count 0, 1, 2, 3, 4. I want to use that here. So line 0, then we have, this is a line 0, line 1, line 2. So line 1, so 1, Google, whatever that, line 2, 1, 1 plus, and so on and so forth, till 10. You can use this. This is not the same as here. In this case, we bring that up all once, like original data. Also, split lines possible. Let's say I want to comment that. I want to simply point, and if I want to read this, then split lines gives me everything in a list. One line will be an element in that list. This is one line. Look at this is the end of that line. Second line, start quote and ending quote here. This is second line. Second line will be the second element in the list. That's what this gives me. So this returns a list of lines. Where each line is an element, a list element. That's what it is. And also we can have a read lines and read lines and read line. This is the same as that. And I want to read, open that file path, read only. If I use read lines, I want to skip this and run this. Size and length. So what is the size? Size 11 lines. So here is we have 11 lines, right? If I want to redo this, see this? It gives me only the line, only what I wanted here, because I know the size 11 lines. For each lines, I want to read. Here, read the lines, then you can read all the lines at once. Read the line means I want to read one line, line by line. That's what it is. In other words, here, let's practice. If I want to do this, then I read all lines. Okay. If I do line singular, If I do singular, then I have one single line. Therefore, if I want to do second line, then then it gives me the second line and third line and fourth lines. If I want to print that and also print, then I can read to first line. This is the first line, read line. So first line is printed. After print, then file pointer goes to the second line. So if I said read line, then it reads the next line. After I read this, then it goes to the next line. So when I do this, print file open, read line, dot read line. Okay. Then this print the first line, and next will print the second line, and next one print the third line. So this one read the third line. How come it is possible? So after reads, file pointer does not return back to the beginning of that files. File pointer, after we reads, then file pointer stops there. Okay. So here is what happens. Open this, and I read lines, and I count the length, how many lines. So I know 11 lines. So it prints 11 lines. After that, I wanted to read the lines. One line for I, the range size. So I want to do this 11 times because I have 11 lines. For each time, I want to read the line, one line at a time. After I read one line, I want to print dash, dash, dash. And then I want to split by sentence is a line. I want to make a sentence by comma. Oh, I don't need to do this, right? I don't need to do this. I want to simply do print line. Let's do this. Yeah, I want to print line, but nothing printed here. How come nothing printed here? That is because after I do this read lines, then pointer points to the end of that files. At the end of that files, if I want to read next line, next line, next lines, then it doesn't move because that is already reached the end of that files. So what should I do? I need to rewind it, which is seq 0. I want to rewind it to the point 0. 0 means beginning of the lines. When I do beginning of the lines, then I can nicely, because at this points to the end of the lines, I want to rewind and restart from the beginning of the lines for 11 times of read line, singular, so that I can make 0, the first line, whatever I read the line, and then number 1, then whatever I read the lines, and read the lines, and read the lines. That's what it is. So this slide, this code gives you a lesson that not only here, the Google Colab, any cases when you read file, then you can use read line methods or read lines method or read methods, all different. But you have to keep in mind when you read it, then file pointer stops at the end of your readings. Okay? If you read a whole, then it goes to the end of that. If you read line by line, then file pointer stops at the end of one line, at the end of each line. So if you want to move it back and forth, then you need to use this seek methods. So rewind. Seek 0 means rewind back to.
I have a question. The seek method, that doesn't have to be inside the for loop.
You can do that. Any points, if you do seek, there's a good points. If you want to make here seek, file, open, seek, and 0, what happens? It keep 11 times first line only, because it goes back, all the first line. At the end of one line, and then go back. One line, go back. One line, go back. Now you fully understand what it is. That is the reason I said, oh, that's a good question. Yeah, and then another homework assignments. Any question? No questions? Okay. This is the end. I know I did this so fast, but